Okay, if I interpreted this question properly, it's like two separate problems. We're given this function and asked to find the equations of any tangent lines to that curve that pass through this point. So we'll focus on this problem, and then hopefully with that guidance, you'll be able to do the second one. Okay, so what we're essentially saying is that if y equals x cubed minus 11, find the equations of two different tangent lines to the graph of that function that also pass through the point 1, negative 11. Okay, so if we think of this point right here as any point on the graph of that function, for any x value, the y value is x cubed minus 11, then the slope between that point and this point is given by this formula. Change in y over the change in x. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So here is the y coordinate of the first point. Here's the y coordinate of the second point. I don't know why that looked up down like that. Okay, and that simplifies to x cubed over x minus 1. Now another expression for the slope of the line tangent to y is given by the first derivative, which is 3x squared. And we want to know when this expression and this expression, what values of x make those equal. So we want to solve this equation right here, which we do by multiplying both sides by x minus 1, factoring out the x squared, and using the zero product property, x is 0 or x is 3 halves. So when x is 0, y prime is 0. That means we want to find the equation of the line with the slope of 0 passing through 1, negative 11. That will be the horizontal line, y equals negative 11. So there's one of your equations right there. When x equals 3 halves, y prime equals 27 fourths, because we're just putting 3 halves in there. Squaring 3 halves is 9 fourths. 3 times 9 fourths, 27 fourths. So to write the equation of a tangent line with this slope passing through 1, negative 11, we can use point slope. Y minus a negative 11 equals the slope times x minus 1. If you want to simplify it, this is what you end up with. So here is a graph depicting the situation. This red graph is the graph of y equals x cubed minus 11. We know that when x is 0, we will have a tangent line to that curve that also passes through 1, negative 11. So the point of tangency is actually 0, negative 11. When x is 0, y is negative 11. And we also know that when the slope, when x is 3 halves or 1.5, that the tangent line at that point will pass through 1, negative 11. And this is the point of tangency, which we put 3 halves in here for x cubed. We get 3 halves cubed is 27 eighths minus 88 eighths. That's negative 61 eighths, which is what this is, negative 7.65. Okay, there you go. Hopefully you can follow that pattern to do the second problem. If you have any questions, post a comment.